Find the derivatives of the following functions. In part A, we got cosine inverse plus x squared quantity square. Cosine inverse. We know that derivative of sine inverse x is 1 over square root of 1 minus x squared. And when we have cosine inverse, that will be negative of this fraction. So this whole thing is some quantity. Okay, it's like u squared, and when we have u squared, this is the inside function, square is the outside function, its derivative is like x squared, so 2u times from the chain rule u prime. Okay, so u is the inside function, so the derivative here is then u square means 2u times u prime. So u is cosine inverse x plus x squared times u prime. So derivative of these two terms, derivative of cosine inverse is just negative of this 1 over root 1 minus x squared plus x squared, and derivative of x squared is just simply 2x. Okay, final, we don't have to simplify. In part B, this is just a simple fraction, and we know that whenever we have a fraction like say u over v, then its derivative is u prime v minus v prime u over v squared. So v is 1 minus secant x and u is tangent x. Okay, so let's find the derivative. On the bottom square, 1 minus secant x quantity square, it's like v square. On the top, derivative of tangent, and we know that derivative of tangent is secant square x, that's the u prime times v is the bottom, 1 minus secant x, okay, minus, that's coming from the formula, minus like the middle, v prime, so derivative of bottom, and derivative of 1 is 0, derivative of secant is secant times tangent, there is a negative sign, so 0 minus, I'm finding derivative of bottom, 0 minus secant tangent, so 0 does not count, so minus, that makes this plus secant times tangent, that's v prime times u, and top is another tangent, maybe tangent square, that times tangent x, so we can write tangent square. Final, do not cancel anything. Okay, let's move to the third question. Here we got e raised to a function. When we have e raised to a function of x, then its derivative is itself times derivative of inside function. Inside is exponent, in this case u prime. Okay, so let's use this. So u is x cubed times natural log of x. So the derivative is itself e raised to x cubed ln x times derivative of top, that's the u prime, and in fact this is a product, x cubed times natural log of x, so we must use product rule here, and we know that whenever we have a product like u times v, the derivative is u prime v plus v prime u. Okay, so x cubed u ln x v, so u prime derivative of x cubed is 3x squared times v is ln x, plus v prime means derivative of ln x, which is 1 over x times u is x cubed. We can cancel x and x cubed, just x squared survives, but we don't have to simplify, we may leave here. Okay, 7 raised to something, it's a number raised to something. Whenever we have a number raised to some function of x, that's an exponential function, and its derivative is always exponential function itself times natural log of base, which is a, times from the chain rule u prime, derivative of inside function, which is an exponent in this case. Some people like ln a in the first, same thing. So here derivative is exponential function, so itself 7 raised to 4x cubed plus x times ln of base 7 times derivative of this function, inside function. So we got two terms, 4x cubed, derivative of 4x cubed is 3 times 4, 12x squared, plus derivative of x is 1. Okay, that's it. We don't have to simplify. Natural log of 7 is, by the way, a decimal number. We can put all the way to the front.